Rain is falling vertically with a speed of 4 meters per second. After some time, winds start blowing. Okay, let's say the rain is falling vertically. Then the wind starts blowing with this speed in the north to south direction. In order to protect himself from a rain, a man standing on the ground should hold his umbrella at an angle given by, let's say this is the man. Okay, let's say this is the man and this is the ground. This is the ground. Okay, the man looking up here, he will see this place as his north, and then this is his south, and then to this side would be his west, and then this side would be his east. So if when rain falls vertically, that means we'll have something of this nature. Rain is falling vertically on this man. So this is the direction of the rain, vertically on the man with a speed of 4 meters per second. So the velocity of the rain is, we can say that it is minus 4 meters per second, since it is along the vertical, the negative y-axis, although the magnitude is 4. So I mean decide to, let me just neglect that for now, but when we get to the calculation, so the velocity of the rain is 4 meters per second and is along the negative y-axis. Okay, after some time, wind starts blowing with a speed of 3 meters per second in the north to south direction. So in the north to south direction, the wind starts blowing, and then of course, in order to protect himself from the rain, a man standing on the ground should hold his umbrella in what direction? So if the wind blows from the north to the south direction, so we should have something of this nature. The wind blowing in this direction with the velocity of 3 meters per second. So velocity of the wind is 3 meters per second. And then what direction will the man set the umbrella in order to protect himself? In order to protect himself, he would set the umbrella in this direction, in a direction that is resultant to the both vectors. So let's say this is P, in order to protect himself, and then the angle will be towards this side from the vertical, from the rain. Okay, as a result, in order to do this, we can bring out the diagram. So let's say this is angle theta, and then this is 4 and this is 3. So if this is 3, is the same thing as if I have it here as 3, since they are parallel. So it means that I have the opposite and I have the adjacent. This is the hypotenuse. If I have the opposite and I have the adjacent, that means I can make use of tan theta. Tan theta, which is opposite of result, angle theta is the arctan of 3 upon 4, which is equal to 38, 36.87. Approximately, we can have 37 degrees. Now, what is the implication? It means that the man would, to protect himself, he will hold the umbrella at 37 degrees away from the vertical towards the north, towards the south. This is the south and this is the vertical, not the north. This is the south, don't forget. This is the north, so not from the north but from the vertical towards the south, from the vertical towards the north. towards the south. Let's solve the next practice problem. Raindrops are falling through the air with a velocity of 3 meters per second. Okay, let's suppose that we have a man. Okay, this man, let's say this is the ground, just like we have in the former example. This man will have his north in this direction, and then his south in this direction. He will be looking at his front as his north, and then the behind as his south, and then the side as his east, then the other side as the west. Now when rain drops, rain has to drop vertically on this man if the man is stationary. Now let's see, raindrops are falling through the air. Through the air the raindrops are falling, and it has to be with this velocity. That means that velocity is not just the velocity of the rain, it's the velocity of the rain that is being affected by the air. So that is the velocity of the rain relative to the air, or relative to the wind, as the case may be. So we can say this is the velocity of the rain relative to the air, and that's equal to 3 meters per second. Now if a north wind, the wind or the air that is being that is affecting the rain is from the is a north wind. A north wind is a wind that comes from the north to the south. So the north wind is like this, is going in this direction, is going in this direction. That's the north wind affecting the rain. That means we'll have the north wind going in this direction. Let's represent one of the wind. These are the winds. Let's represent them with this. So this is the velocity of the wind or the air. Since we are using air, we just need to stay with it. Air and wind the same. So velocity of the air is given as 18 kilometer per hour. So let's quickly convert that. 18 kilometer per hour, so that is 18 kilo is 1000, so that's 1000. Then the hour is 3600 seconds. So if you do this correctly, you should arrive at okay, so you should have 5 meters per second. So instead of 18, we are working with meter per seconds. Then we should have velocity of the air, we should have it as 5 meters per second. And don't forget that the velocity of the air, since it is given as the velocity of the air, is the same as the velocity of the air relative to the ground. So in other words, we need to find the rain that will fall on the man has to be the rain that has a velocity relative to the ground, and we do not have that in this space. So we need to find the resultant of this is the velocity. The resultant of these velocities will give us the velocity of the rain relative to the ground. So the velocity of the rain relative to the ground is that of the rain that the man will feel on his head. So we are going to have it in this manner. Let's find the velocity of the rain relative to the ground, which is equal to the velocity of the rain to the air plus the velocity of the air to the ground. So since it's a right angle triangle, we may not need to do any other thing. We can just go ahead with the right angle formula, or we may say that, or we may first of all represent them in vector, in their vector form. The velocity of the rain to the air, that is -3, because it's towards the negative direction. So I can represent it with j. J means towards the y axis, and x axis is I. So VAG, which is the velocity of the air relative to the ground, I can represent it as 5. Then it is towards the negative x-axis, so that's supposed to be minus that's supposed to be minus 5I is on the x-axis. So it's the same thing as if I do it in the Pythagorean method. So I will have I'll have it as minus 3 squared plus minus 5 squared. So it is the same as what I have been doing in my former videos. So we'll have something of this nature. That's the root of 9 and 25. So the root of 9 plus 25 is the root of 34, and the square root of 34 is 5.83 meter per second. So 5.83 meter per second is the velocity of the rain to the ground. So that is 5.8 meter per second. In other words, okay, let's see, find the direction in which the drops appear to fall on a person that is walking north at 6 kilometers per hour. So the direction it will fall on a person that is walking to the north is this direction. It is that same direction. Let's call the direction angle theta. So suppose this is the person now. That person is walking towards the north at 6 kilometers. Let's convert 6 kilometers. So to convert 6 kilometers, let me clear this field. So 6 kilometers, that is 6 kilo is 1000, so that's 10 raised to power 3, then upon hour, and the hour in seconds is 3600. So if you do that, that's very simple. So we'll have 6000 divided by 3600. So we'll have 5 over 3, which is 1.67 meter per second. So this man moves 1.6 meter per second. 1.6 meters per second. And then he will feel the wind, he will feel the rain relative to the ground. He will feel that rain in this direction. You will feel it at this angle theta. And don't forget that this velocity is 5.8 meter per second, and this is 1.6. Now let's find the direction at angle theta. The direction of angle theta, since we have this as the hypotenuse and we have this as the adjacent, so we have adjacent A and we have the hypotenuse, so we can use cos using the SOHCAHTOA. I just use SOHCAHTOA. So the cos theta is the adjacent, which is 1.6, upon the hypotenuse, which is 5.8. As a result, the theta will be equal to arc cos of 1.6 upon 5.8, and that's equal to 73.99 degrees. So it means that the direction in which the drops we appear to fall on that man is 73.99 degrees. Now let's find the direction properly. Now we know that the angle is this, and this is the north for that man. This is the north. So, and this is the, let's say this is the vertical for the man, and this is also from the north. of the man. So we can say that it is 75.99 degrees away from the north. Or more precisely, we can do it like this. Since the rain is supposed to fall vertically this way, the rain is supposed to fall vertically this way, then since this angle is 73.98, we can find this other angle by saying 90 minus 73.98. So 90 minus our former answer will be 16 degrees. So it means that from the vertical, the rain will fall 16 degrees from the vertical to the north. 16 degrees from the vertical to the north. I think this is more precise. From 16 degrees from the vertical to the north. That is it. Let's solve the next problem. Okay, rain is falling vertically. Let's say this is the rain. This is the velocity of the rain. The rain is falling on a woman. So velocity of the rain to the ground, since it is given as the velocity of the rain is the same as the velocity of the rain to the ground, so we can have the woman right here. This is the woman. The woman will have is north in this direction. The woman have is south in this direction, then is east in this direction, and then let's put the west in this direction. As a result, the woman rides a bicycle which speeds at this from the north to the south. So the woman is in this direction, moving in this direction from the north to the south at this velocity. So this is the velocity of the woman to the ground, and that's 10 meters per second. The velocity of the rain to the ground, that is 30 meters per second. Now the question says, what is the direction in which she should hold her umbrella? The direction in which you hold our umbrella is the resultant to this vector, and that's the velocity of the rain to the woman. So because the velocity of the rain to the woman is the velocity of the rain to the ground plus the velocity of the ground to the woman. So we can find this. Since it's a right angle triangle, the direction we are looking for, this is it. This is the resultant. This is the rain to the woman. So this is where it is found at angle theta. This is the vertical axis. So that means it is at theta away from the vertical towards the south. Okay, so let's find it. Since this is 10, we can say that this is the vertical, this is the x-axis component, so it is the same as this place. We have angle theta in this place, and this is 10, and then this is 30. So since we have the opposite and we have the adjacent, we can make use of tan from SOHCAHTOA. That means tan theta opposite, which is 1, upon the adjacent, which is 30, that's 10 over 30, which is the same thing as 1 over 30. So we have theta to be arctan of 1 upon 3, 1 over 3. So theta is equal to arctan of 3. The arctan of 1 upon 3 is equal to 18.43, 18.43 degrees. So theta is 18.4 degrees. So the direction is 18.43 degrees away from the so that's it. The question says to a person moving eastward. So let's say this is the person. The person move. Let's say this is the east of this person. The person move east. That means this is the west of this person. Then this should be the north, and this should be the south of that person probably. Now the rain falls vertically on this person. Okay, to a person moving eastward, this person is moving eastward with a velocity. Okay, this is the velocity of the person to the ground is equal to 4.8 kilometer per hour. Now rain appears to fall vertically downward with a speed, so this is the velocity of the person, of the rain to the person, because the person is the one seeing it. And that's why the question says to a person moving eastward with a velocity of this. So the person is moving with this velocity, that is the velocity of the person to the ground, but that person sees rain. The rain appears to that person as to be falling vertically with this speed. That means this is the speed of the rain to that person. So we have it as 6.4 kilometer per hour is the relative velocity of the rain to that person. Now the question says find the actual speed and direction of the rain. So we want to find the actual speed and the direction of the rain. That is the velocity of the rain to the ground is the actual speed of the rain. You know, velocity of the rain to the ground is the same thing as the velocity of the rain. So that is equal, since this is approaching the positive x-axis, I mean the negative y-axis, I can write it as minus 6.4j. Then this is along the positive x-axis, then I can write it as plus 4.8i. 4.8i. So to find the magnitude, I can say that the VRG, since it's a right angle triangle, I can make use of the Pythagorean formula. The Pythagorean formula, we have something of this nature. We have 6.4 here, and then we have 4.8 here. So we can say that, and we are looking for this. This is VRG or VR. Notice that this vector and this 4.8, they are the same because they are parallel to each other. So this is a right angle triangle, where this is the hypotenuse. So it means that VRG is equal, the square of this according to that formula is 4.8 squared plus 6.4 squared. So I can put it around. If I make VRG the subject, that would be the square root of 4.8 squared plus 6.4 squared. So it's the same thing up here as well, as the square root of minus 6.4 squared plus 4.8 squared. So eventually you will have this answer, which is equal to 8 meter per second. So the actual speed of the rain is 8 meter per second. To find the direction has to be from the vertical. So let's see the actual direction, which is supposed to be angle theta. That means we have angle theta right here. So we have the opposite and we have the adjacent. So we can make use of tan theta, which is opposite upon adjacent, 6.4. So 4.8 divided by 6.4, that's actually equal to 0.75. And then the arctan of that answer So theta is the arctan of 0.8 over 0, I mean 4.8 over 6.4. Okay, that is equal to 36.8 degrees away from the vertical. Away from the vertical to the east. Since the boy is along the east, is moving eastward, so it's towards the east, to the east. All right, thanks for watching. Make sure you subscribe to this channel for more.